Yeah. Hi, everyone. My name is Upal Mahbub, and I serve as the chair of the IEEE San Diego section, as well as the IEEE Computer Society San Diego chapter. Welcome to the fourth and fifth two back-to-back talks for our 2025 invited seminar series. Today's virtual event is co-hosted by the Computer Society chapters of San Antonio, Dallas, San Fernando Valley, Hawaii, and Palos sections, as well as the Computational Intelligence Society chapter of San Diego and EMB chapter of San Fernando Valley section. We have Open Research Institute Incorporation as our media partner for this entire series. With that, I'd hand over the floor to Sanjay Poddar to introduce our invited speakers.
Hi guys, my name is Sanjay. I'm the regional coordinator for speaking activities for Region 5 and 6. Uh, we have two distinguished speakers. Vijay. Vijay is an IT consultant. He specializes in healthcare, payer technology with expertise in system integration, enterprise architect, and data analytics. He has extensive experience working with national health plans such as United Healthcare, Cigna, and Blue Shield of California. Vijay has also been in leadership positions which entail end-to-end implementations and integration of complex healthcare systems like TriZetto, Facets, and Medicaid management information systems. His focus includes regulatory compliance too and process optimization, the development of customized IT solutions that streamline operations in the healthcare domain. Vijay work spans roles in project management, solution architect, and system analysis, making him a versatile expert in designing resilient and scalable systems that meet both the technical and the regulatory standards within the healthcare environment. His passion lies in driving delivery and excellence and transforming healthcare IT landscapes through innovation and system integration strategies. I here welcome Vijay. Please do take the floor and start with your presentation.
Okay. Thank you, Sanjay. Thanks for the introduction, and thanks, Upal, for hosting the event. So good evening, everyone. My name is Vijay Mekala, and I'm delighted to be here today. We'll discuss the topic that is truly shaping the future of healthcare, that is AI-driven healthcare transformation in the cloud. So in today's presentation, we'll explore how artificial intelligence and cloud technologies are transforming healthcare IT, particularly at the payer sector. When I say payer sector, I'm talking about all the major health insurance companies like the Cignas, Aetnas, United Healthcare, the Blue Cross Blue Shield companies. So those are the bigger companies, but there are TPAs, the smaller third-party administrators that do a chunk of claim adjudication as well. So I'm talking all of them combined as payers, and the sector is payer sector. And today's topic will diverge into how innovations are driving better outcomes for patients and organizations alike. Moving on. Okay, let me change. Okay, the healthcare industry
Vijay, we
is
don't
evolving.
see your. Sorry, Vijay, we don't see your screen.
Sorry. I thought I was sharing my screen. My bad. So let me share my screen. Can you see my screen now?
Yes, we can.
Okay. Yeah. So let me go back. So this was the topic that I was talking about, embracing the future, AI-driven healthcare transformation in the cloud. So moving on, the healthcare industry is evolving at a rapid pace, and the integration of AI and cloud technologies are at the forefront of this transformation. For today's topic, we'll focus on three key areas. Those are systems integration, enterprise architecture, and data analytics, and how they are reshaping the payer sector. We'll also discuss about the strategies of compliance, optimization of IT solutions, and we'll draw some insights from real world examples. And by end of this session, you will gain a clear understanding of the challenges and the opportunities that are there that these advanced technologies and advancement in the technologies present currently. So let's move on to the next slide. The healthcare landscape is undergoing a dramatic shift driven by the convergence of data availability and advancements in AI and machine learning and the adoption of cloud computing. For the payers, this transformation opens a lot of doors to improve the patient care, streamline the operations and reduce the costs, which in turn helps reducing the cost or passing on the cost reductions to the members or the end users. Key to this change is that the payer sector is quick in adopting of the technologies that can optimize the care management and member engagement. So as we progress in this discussion, I'll highlight how these trends support the shift from value-based care and enablement of innovative solutions across healthcare ecosystems. One major driver of this transformation is the shift from fee-for-service models to value-based care models. So if you take the current healthcare models or legacy healthcare models, all of the legacy healthcare models are driven by fee-for-service. Basically, you will be paying your monthly payments to the insurance company, or your employer would be paying the fees for the service for the insurance companies. But there is a paradigm shift happening from fee for service to value-based care models, wherein people are getting incentivized for quality rather than the volume that the insurance companies are providing. This transition places data and analytics at the center of the care coordination and health management. Currently, AI-powered analytics allow payers to analyze immense data sets to identify patterns, predict the risks, and personalize care interventions. These capabilities are essential for reducing unnecessary utilization, improving the care coordination, and focusing resources on high-risk populations, which in turn, helps reducing the costs. Please let me know if I'm going too fast or if you have any questions so far. I can stop at any moment and address any of your concerns. So the AI-driven analytics are revolutionizing the care management by the payers, for the payers rather. By leveraging the machine learning, organizations can process the claim data, EHR. When I say EHR, I'm referring to electronic health records of the patients, and even the patient-generated data, which are coming from the smart devices like the pedometers, the phones, the Fitbits, and other health-related apps that are available on all of the smartphones. So combined, all of this data helps to personalize and preventive care medications or tailor the preventive care programs to each individual needs rather than looking at a bigger population, right? We can further dive into each individual and customize the program to the individual that we are looking for. So the benefits of this would be twofold: better patient outcomes and significant cost reductions. So basically that AI models can enable proactive interventions that can minimize compliance and reduce the hospitalization rates, meaning the readmissions of any patient that is deviating from the current care program that they are enrolled in. So we can intervene those and reduce the readmission and hospitalization rates by enabling the AI models predict better programs for each individual. So one of the areas that would be helping in this regard in implementing all of these AI models is cloud computing. So cloud computing has become a cornerstone for scalable and agile health transformation. So any of the cloud native architecture that are being implemented at all these major health payers can handle immense data volumes, which the legacy or traditional models are unable to do. So I'll give you an example or perspective. So less than 5 years ago, 90% of the health population claims data or claim adjudication data is being managed on legacy, AS400 driven applications or mainframe systems, which are very cumbersome from a management standpoint, also very complex and very rigid systems. So they don't have the capability to either expand the services or on need basis, just like cloud computing. I'll give one particular example. If you pretty much know that the last quarter of the year, starting from October to December, will be open enrollment, wherein majority of the employers will be offering changes to the health plans. Or, sorry, is there a question? Yeah, if you are not talking, can you guys please go on mute? Thank you. Yeah, so I was talking about the enrollment, right? So wherein the cloud, the computing power is needed much more during the last quarter, wherein we'll have to go through a vast set of data to support the open enrollment. So the rigid systems in the legacy world are not capable of handling those data sets. However, with the advent of cloud native architectures and the newer systems, we now are capable of handling the data or the systems much more easily by taking advantage of the cloud platforms, pre-built services, and the custom infrastructures that these cloud native service providers provide to the health payers. So we are also seeing a rise of digital first health plans, meaning that how the payer systems are interacting with their members, be it through their mobile apps or wearables or telehealth platforms. Members can gain access to the personalized and convenient tools for managing their health. These tools not only enhance member engagement, but also generate valuable data set, which can be leveraged back again by the payers and creating a digital first health plans as a win-win situation for both members and payers. So let's look at some of the real world examples, right? Major health plans have successfully used AI and cloud platforms to drive proactive healthcare solutions. For instance, AI-powered analytics have enabled payers to predict member health risks, basically going through the desensitized data. When I say desensitized, I'm talking about all the HIPAA and privacy laws. All these AI-powered analytics can leverage the de-identified data, and those models can be adjusted or can predict the member health risks and design personalized care strategies for each member level. And at the same time, cloud native architecture has allowed these organizations to scale the infrastructure and improve their agility. So those two are the two case studies that I want to provide, which has, these two technologies has transformed the entire spectrum of payer health solutions. Coming to the challenges, of course, there will be challenges just like with any other industry. First and foremost challenge would be data security and privacy. Given that the sensitive nature of the health information, it is essential for the payers to implement the regulations like HIPAA and any other regulatory compliances that are needed by be it Medicare or Medicaid or CMS or state and local regulations or compliances have to be met. So those could be challenges that the health payers would be having. In addition to that, I see that there could be a potential skill gap from a healthcare industry standpoint. As I was stating earlier, the healthcare IT industry, for the most part of the last 5 years, has been changing, but it's prior to that it was all rigid systems, and they are mainframe driven systems, which are with that, the people that are in there, the IT people that are there are also well versed in those, but they need to be cross-trained or trained for the newer AI and cloud technologies. That's going to be another challenge that the health insurance companies are paying. Coming to the opportunities, right? Despite these challenges, opportunities presented by AI and cloud technologies are immense. Payers who embrace these advancements can improve patient outcomes, improve their operational efficiencies, deliver personalized and engaging experience to the members, and also by leveraging the power of cloud computing, they can position themselves at the forefront of healthcare innovation by reducing the costs and again passing on the cost back or cost reductions back to the members and providing a competitive edge within the insurance sector. In conclusion, AI and cloud technologies are revolutionizing the healthcare landscape, especially in the payer sector. So with the advent of AI-driven analytics and cloud-native architecture and digital-first health plans, payers can achieve better care management, improved efficiency, and member engagement. As we navigate these changes, it's crucial for us to address all of these, capitalizing on the vast opportunities with the technologies that are present. With that, I conclude my presentation, and I'm open for any questions or any feedback that you have, or any comments or concerns that you have. I can address any of those.
Thank you, Vijay. That was a great talk. Definitely learns a few things from it. So if anybody has any questions, we have got a few minutes to spare. If anybody has any questions, or okay, so there is a question from Bibu. So he's asking, any systems directed at home healthcare? You're on speaker.
Yeah. Sorry. I was on. Okay. So the question is not clear for me. So I'm assuming that you're talking about home healthcare. Is it? Can you elaborate on that one?
Okay. So can you hear me?
Yes.
Can you hear
Yes.
me?
Yes.
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 So basically, I'm kind of envisioning a system where, you have 24/7 data collection at home based on sensors, and that data is kind of analyzed in your privacy at home, and you make the kind of conclusions that you are talking of. Maybe if you go and see a doctor because something is.
Yeah, I understand your question. So unfortunately, the question that you're talking about is more from a medical device management standpoint. Where I'm coming from is more from healthcare payers, that is the insurance company standpoint, because they have a much more larger spectrum of data to look at, rather than your individual directed question from a healthcare standpoint, right? So they will be looking at not only the information coming in from your individual, of course, if that data is shared with the health insurance company, yes, it can be monitored. But I'm talking about the previous health records of the members that are taking care from the insurance company, meaning what are the hospital visits, what are the key diagnosis codes or key procedure codes that a member has gone through or rendered services from any particular provider. So that's what I'm talking about, Bihu.
Yeah, understood. I think that's one part of it, obviously. Okay.
Yeah.
But I was thinking, even from insurance companies' point of view, actually, they could say that if you deploy this system, I am going to lower your insurance because you can do some preventive.
Yes. So that's
healthcare type of things.
that's the wearable aspect that I've talked about, right?
Okay.
Data coming from your wearables or smartphones, be it your Fitbit. So some of the plans nowadays are providing these wearables at free of cost, with the caveat that information, whatever is collected from those, can be used by these health insurance companies to better predict your health outcomes and predict the financial models from there. How effectively they can use that data coming in from those wearables to predict the next year's premiums for those individuals as well.
Okay, thank you.
Yeah.
Okay. Thank you, Vivi, for your question, and thanks, Vijay. It was great. So let's move
Roman,
on.
looks like Roman has a question. So
can we can take this at the end?
Okay, sure.
So that we can have Jitendra give his talk, and then we will come back to your question at the end, because the last 10-15 minutes would just be dedicated to
Understood.
questions. Yeah. So let me introduce you to Jitendra Jain. He's our next speaker, and he's a technology leader with over 16 years of experience in AI, fintech, and retail. He essentially, his work involves driving innovations, which are in advanced AI solution. He also holds a patent in AI advancements in fintech. And he has been in the industry with his dedication and technological progress. He has been able to complete several large-scale projects. Currently, he is engaged in IEEE and also an IEEE senior member. He has contributed a lot to the global tech community within IEEE too, and he focuses on a lot of scalable AI-driven systems that solve complex challenges and deliver impactful outcomes. He's also an active reviewer of international journals and conferences. So combining with his technical expertise, he's definitely a very thoughtful leader. So thank you, Jitendra, for coming to us and delivering the speech. I'll give you the floor, and just unmute yourself and please get your presentation going.
Yeah, thank you, Sanjay, for the kind word. Good evening, everyone. I'm here to present something about finance and retail. Let me share my screen. Yeah. Hopefully my screen is visible.
Yes, we can see that.
Okay, perfect. So I'm here to talk about AI-powered enterprise solution, transforming finance and retail. And this is part of IEEE Computer Science Society San Diego invited seminar series. And right now I work at Cognizant USA as a senior engineer. A bit about my background. I'm a software engineer with over 17 years of experience in financial technology, majorly. And I'm an inventor with a granted patent from USPTO, US Patent Office, and a member of Core Technology Council. My expertise spans across artificial intelligence, cloud computing, and software engineering for building enterprise software solutions. So how AI is how AI is enhancing the finance and retail. In finance applications, AI is excellent in fraud detection, reducing fraudulent transactions by up to 55%. This represents millions in saved losses for financial institutions. Additionally, algorithmic trading and risk assessment have become significantly more precise with machine learning models, allowing for split-second decisions based on vast amount of market data at disposal. In retail, AI-powered inventory management is reducing stock out by 30%, directly impacting bottom line by ensuring products are available when customers want them on the aisle. Smart systems are optimizing supply chain and creating personalized shopping experiences that dramatically increase customer satisfaction and loyalty. The market growth numbers are impressive. AI in retail will reach around $31 billion by 2028, growing at a more than 21% CAGR, while the finance market for AI is projected to hit around $50 billion by 2030, with an even more impressive CAGR of 33%. To implement AI at enterprise scale, the technical foundation is critical, and that's where event-driven architecture has emerged as a backbone for building a scalable AI implementation. For real-time processing, event-driven architecture enables instant data handling through asynchronous communication. This means systems can react to events as they happen rather than through periodic batch processing. In retail specifically, companies can react to demand spikes 40% faster with event-driven architecture systems, allowing for dynamic adjustment to inventory and pricing. Event-driven architecture facilitates seamless integration by enabling continuous data flow for AI training as well as AI inference. This provides essential flexibility and resilience for enterprise systems that must adapt to changing conditions and requirements. Key technologies making this possible include Apache Kafka, Amazon Event Bridge, a managed service from AWS, and RabbitMQ, and many more similar distributed scalable technologies, which leads the field in connecting event producers, brokers, and consumers in a reliable, scalable way. Once the architecture foundation is in place, optimizing AI ML operations becomes critical for the enterprise success. For training optimization, distributed training cuts model training time by up to a big chunk, allowing for faster iteration and deployment of new models. Transfer learning is another powerful technique that lets models leverage pre-existing knowledge rather than learning everything from scratch. Second one, inference improvement. Inference improvement focuses on the production deployment of AI models. Model quantization reduces model size by 4x without accuracy losses, making deployment more efficient. Hardware acceleration with GPUs and CPUs dramatically speeds processing for real-time applications, so it includes cost. And the last one, edge computing, which brings AI closer to data sources, reducing latency by up to 90% and enabling faster decision-making at the point of action rather than requiring round trip to cloud data center. Scaling AI presents significant challenges in infrastructure cost, data management, model maintenance. Let's go through these one by one. First one is AI as a service. This allows companies to leverage outsourced AI infrastructure rather than building everything in-house, reducing capital expenditure. Serverless computing. This provides 50% infrastructure cost reduction by ensuring you only pay for what you use rather than maintaining constantly running server. Cloud solutions. This offers a good amount of savings through migrating compared to on-premise premise AI infrastructure, with the added benefit of scalability, reduced maintenance. Open source tools like TensorFlow, PyTorch, or Kubeflow eliminate expensive licensing costs while providing state-of-the-art capability. And the last one is AutoML. This automates the model selection and optimization process, reducing the need for expensive data science talent for every project. And now I'm going to talk about a case study. AI-powered loan processing for a leading bank. So this study is for a leading bank, and if you, as per this architecture diagram, this is part of the whole architecture. This is all about income verification for a particular application for a loan to a bank. So it starts with a application through a applicant. An applicant gives all the details, submits all his credentials and his details, and gives the relevant document to the bank. Now, bank has multiple ways to verify and calculate the income. One of the ways is calling credit bureau API to get the data, which includes income data. And the second part is document. The challenge with the document is it's a cumbersome job and someone has to process them manually. Those are people who are working at banks dedicated for processing documents. And at the end, there's a reconcile of that data which the bank gets from the credit bureau and income document. So how? Yeah. Now this particular piece, which is a manual process, which is document processing, it is something which is automated with help of AI ML models, and this is divided into multiple pieces. And this leverages cloud computing, event-driven architecture. It starts with data capture, which is all about capturing the data from the systems, different type of document. Second is classification. This is where the documents are classified with the help of ML models, that what document belongs to what category, like driving license, SSN, or income documents like W2, pay stub, or 1099. All these classification happen at the second phase. And third phase is where extraction happens. This is where the OCR comes into picture, optical character recognition. The data is extracted from these classified documents with help of ML models, which are working on top of optical character recognition technology. And after that, the enrichment happens by the software on the data extracted from the document. And then so all documents might not be processed by the AI augmented solution. So some documents go to review and validation. And as they go through review and validation, the idea is that the work or the percentage of the documents to be reviewed and validated manually is reduced a lot. And the last piece is this data is going to the downstream for further processing on the loan origination, loan processing. The results are remarkable. 100% faster processing means loan approval now take minutes instead of are dramatically improving customer satisfaction and competitive advantage. Staff have experienced 90% less manual work, freeing them from mundane tasks for higher value activities that require better human judgment and creativity. And the last one, there's been a 25% improvement in accuracy with less errors and reduced risk in loan assessment, directly impacting the bank's financial health. This is another real world impact in retail driving customer engagement and sales. As you can see in this chart, virtual try-on technology has had the most dramatic impact, with Sephora Virtual Artist AR with AI integration, showing remarkable results in both customer engagement and conversion rate. AI-powered recommendation engine and chatbot significantly boost customer satisfaction while reducing support costs. The data shows that customers spend more when they receive personalized recommendations and can get immediate assistance. With great power comes great responsibility. Responsible AI deployment requires addressing several critical ethical considerations. Addressing bias is paramount. Diverse training data and fairness metrics ensure equitable AI systems that do not perpetuate or amplify existing social biases. Transparency through explainable AI methods clarifies how decisions are made, building trust with customers and regulators alike. Data privacy protection through robust governance policies safeguards sensitive financial and personal information, which is particularly critical in finance and retail, where vast amount of customer data are processed. Regulatory compliance with GDPR, CCPA, and industry-specific regulations is not optional. It's essential for continued operation and avoiding costly penalties later on. The future of AI in retail. Looking ahead, several emerging trends will shape the future of AI in these industries. Generative AI is creating new designs and personalized content for customers, moving beyond analytics to creative applications that enhance product and experiences for the customer. Predictive learning allows training on decentralized data while preserving privacy, addressing one of the key concerns in AI deployment. AI IoT convergence is enabling smart retail spaces and autonomous financial systems that blend the physical and digital world seamlessly. And the last one is hyper-personalization. This delivers unique tailored experiences to each customer, moving beyond segmentation to truly individual experiences. Thank you. I welcome your questions about any specific aspect of AI in finance and retail, what we have discussed.
Thank you, Jitender. That was a wonderful talk. Guys, I welcome anybody who has any questions. I think we have a pending question remaining from Roman. So let's go with that first. So that was directed towards Vijay. Vijay, can you please address this question from Roman? There is a concern that the smaller provider AI systems, such as in rural systems, may not be large enough to de-anonymize patients. So Vijay, can you think of, yeah, can you please do help us answer that? You're on mute, by the way.
Let me address that question. So the question is, how come the data from rural settings can be de-anonymized for training the AI models, right? So if you look at the bigger picture, the health insurance industry is not restricted to rural area or a small setting within a rural area or a small group of hospitals within a rural area, right? So the data gathered by the bigger health insurance company is nationwide. That if you take an example of United Healthcare, they have millions of members across the board. So if you do consideration, it's easy to anonymize and de-identify the data, remove all the PHI, so that we are in compliance with HIPAA and consent laws while training the model. So we will not be taking a smaller set of data, but we'll be feeding the model with a bigger set of data across the board at large scale. Hope that answers your question.
So Roman had a follow-up question as well. For both solution spaces, what risk methods did you use to mitigate bias for your solutions?
So where is that? So from a risk mitigation standpoint, right? So from a bias risk mitigation, give me 1 second. So let me stop sharing my screen and I'll try to bring up relevant information here. So I don't have the presentation handy that we have detailing the AI model itself, but I can go over at high level what we have done, right? So while building the AI model, so minimizing the bias and protecting the data privacy, we have taken into consideration on removing all the, like I said, right, all the PHI and relevant information that includes removing the member names, gender information from the data set, and removing of any of all the identifiers that could specifically, target a specific group. We have de-identified and removed all of that. That will lower the potential risk of, biases that are there in the systems. Is there a follow-up question?
I can add to that. I
Yeah.
can add to the question. So about the risk methods, right? So the thing is that first of all, the important data or the data which is PII or PCI data is not something which is feed directly. It's kind of synthetic data made for those purposes, especially. And moreover, the data itself is clean and diverse to build a solution which is not biased at all. When I say at all, is not something possible, but the idea is to take it to that extreme where the data is not biased at all. Okay. This is one approach. The other is how to keep the data secure at rest and while it is on the move with the help of tokenization of data like SSN, and same thing for card number. Encryption used to help earlier, but now tokenization is something which is on top of encryption, which helps a lot to secure the data, not only for AI, but in general.
Okay, this is Roman, and I attended a webinar earlier today put on by a couple of attorneys, and after a couple of hours, and it wasn't exhaustive, even after 2 hours, there were lots of case studies of systems that had been put in place, and then later ran into a number of legal issues where sometimes these solutions had to be shut down or greatly modified because there were the traditional methods of simply securing data or encrypting certain aspects of the data or trying to anonymize the data in the normal fashion were not sufficient. And the other thing too is that a lot of times you're taking in federated data, and you don't know what where the data came from, how it was generated, that sort of thing. So you've got a lot of issues there, and it seems as though the new practice is to bring a person on board who does artificial intelligence risk management, where they specialize on looking at those kinds of problem areas that you're going to run into before the systems are launched. And I didn't hear much about that, but that's usually a very big potential stumbling block. And I thought it'd be interesting to hear from each of you how that might have been dealt with, because certainly the technical aspects are seemingly solvable, but it's just that you run into a lot of ancillary effects or downstream effects that bring those solutions, to question.
Yeah. So, Roman, points well taken, right? So I completely agree that AI being relatively new, and when it comes to commercialization of the AI aspect, it's still in infant stage, I would say. So as the technology is evolving, and as you said, right, there are some legal considerations that need to be made. So companies are uncovering those and trying to mitigate with from a regulatory standpoint. Currently, there is no regulatory authority that determines, okay, what is the, how to determine, what is considered as a bias within the AI system. There is no regulatory board as such that can authoritatively say that, okay, this is an inbuilt bias or this is not. Those things, as you said, right, has to be taken up with a bigger discussion or forum. We are more, as part of our presentation, we are more involved in the technical implementation of the challenges that we have. But that's a point taken, Roman.
I just want to
Thank
add
you.
my point of view.
Yeah.
So when you go strategically, right, so there are multiple pieces to this. I am an engineer or a developer, but I have a team when I work in at least in a big company. I have risk management and I have legal. Whenever I'm trying to build a solution, before I build a solution, I have to go through all these hops and let them explain what I'm doing. And they have some recommendation to me. And I have to follow that. That takes time and it's difficult to implement. So what I'm trying to say, if you're building something for a long term, then you will go through the process in the right way. It's slow, it's hard, it takes time. But from my experience, I have worked only in big companies, not big tech, big companies, where every process is going through every step goes through a big approvals and process. to make it work. And it's not like I will do everything in first go. It's an iterative process. How it's behaving, how we are working on it, how it's giving the output, and what are the risks and challenges with that particular solution. And all solutions might not work right away. Some solutions will be shut down in between. Some are never kick off, and some solutions which are going to production also. But all this risk mitigation and calculation and what I should say, strategy comes into picture to build the solution. And again, it's a long-term process to build and execute and let it run in production with continuous evaluation at regular interval of time.
Thank you.
Thank you, Ramon.
So guys, does anybody have any further questions for our speakers? I would take that as a no. Actually, we have got a okay. Thanks, John. Thanks for attending. So guys, I believe we do not have any further questions from our audience. So I thank Jitender and Vijay for taking up the speaking opportunity and delivering their experience and knowledge around the upcoming AI revolution. Thank you so much for your time.
Thank you.
You have a good evening ahead. Thank you, guys.
Thank you. Bye.